Okay. Okay, and thank you for everyone who came to this presentation. And I've got a couple of friends who are here to support me. And thank you for spending time here. And my name is Andrea, and I'm from Sydney, Australia. My university research is in the area of audio-visual translations. The topic of today's presentation is on the accuracy of automated subtitles on learning. This is the overview of my presentation today. So in this presentation, I'm actually combining findings from my master's research, which hasn't been presented before. So this is the first time that I have ever presented the results, and also combine the contents from a book chapter that I've written recently on second language learning with captions. And I just got notified that the chapter is going to be published next year. So it is a good news. And usually captions refers to on-screen text that matches the spoken language in the video. Subtitle translates spoken audio into the viewer's first language. So I will be using the term subtitle throughout this presentation to refer to both captions and subtitles. I am quite sure many of you have experience in reading subtitles on television, movie, or online courses, or even create subtitles yourself. Do you know, every time that you read subtitle, you have performed a very complex processing without you even knowing. When we learn, our brain works like a system that takes in information, processes it, and stores it for later. One way we can improve learning is by using multiple senses or sensory systems inside our body. For example, reading and listening at the same time. Research shows that subtitles can help us understand and learn better. Because they reinforce what we hear with what we see. Okay. My research focuses on two important ideas about how we process information and how we present information in a way that can improve learning. Both of these theories that I will be talking about recognize that our working memory has limits. Working memory is the part of our brain that processes information. So the first framework is the dual coding theory. It suggests that our brain can process both verbal and nonverbal information at the same time through two different channels. One is for hearing and one is for seeing. These two systems work independently, but at the same time, they are also connected. These connections help us to learn and understand better because the brain can activate and use information from both systems through either words or images. So the second framework that I use in my research is the cognitive load theory, and it is a theory developed by Sweller. This theory focuses on how to design learning materials in a way that makes it easier for our brain to process. It highlights three types of cognitive load. And before this particular research, we are only focusing on the extraneous load, which is about how information is presented. This is actually the only load that within the theory that we can manipulate or we can change. And it also related to instructional designs. If materials are too complex or they include unnecessary details or unnecessary information, they can overwhelm the brain's capacity to process all the information at the same time. And as a result, make it a bit harder to learn it. With more and more educational videos being used online, there's a huge demand for subtitles. The challenge is to create these subtitles quickly and in a way that is not very expensive. So money is always a problem. High quality subtitles made by professionals are great, but they take a lot of time and also money to produce. To give you some idea of how much work needs to go into creating high quality subtitles, a 5 minutes video extract can take at least up to 6 to 8 hours or even more to create accurate professional subtitles. So it is safe to say for every 1 minute video duration, it takes about at least 1 hour subtitling time. This includes listening, transcribing, timing the text, creating the timecode, or even rephrasing the text to fit in the limited space and time. And of course, making sure everything lines up perfectly with the video. So on the other hand, automated subtitles are much cheaper and faster. So we can actually create our own automated subtitles online now, like everybody can do it, but they are often not quite accurate. So I want to find out how automated subtitles affect learning. Can they really help students understand the material, even with errors? I'm comparing three types of subtitles. One is automated subtitles, which is used as is, like generated online. The other one is corrected subtitles. The corrected subtitles is the one that I only corrected the text error and the subtitle remains verbatim. And also the no subtitles as the study control. I will be looking at how these different subtitles affect students' comprehension and their cognitive load in how the student perceive their own brain or themselves to work and to understand the content. At the time I did my research in 2016, it is my master research. There were no studies that specifically looked at how automated subtitles impact learning in educational videos. Many studies focus on movies instead. So this study is quantitative with a between group pre-test, post-test design. I use a convenient sample of 92 students studying for a diploma in economics. Over 80% of the students come from a non-English speaking background. All the data was collected in a classroom setting, which is an authentic experimental setting. The students were divided into 3 subtitle groups, just as I was explained, and I measured comprehension score using multiple choices related to the video content and also self-report cognitive load rating. The student watched a 25 minutes extract from a 50 minutes lecture on the topic of supply and demand, the video I downloaded online. So this is actually the study procedure. So we have the pre-test, and then we watch the video, and then student rate cognitive load, rating, self-report, and then a post-test of 30 multiple choice questions, which include the 10 pre-test questions. And I analyzed the data using one-way ANOVA with a 0.05 significant levels. So this is actually what it is like to the student when they rate their cognitive load questions. There are 13 of them. And this is how it was like to look at the automated subtitles on the left side, and then also the corrected subtitles on the right side. And the table shows the equivalence of the automated subtitles in the text and also the corrected subtitles that I have corrected the error, the text error. So we expected students to perform better in the corrected subtitles group, of course, because we already corrected all the errors. However, our results show no significance in both comprehension and cognitive load rating. So there are 2 possible reasons for the non-significant results. First, it is the verbatim corrected subtitles are just too fast for students to process, given the content were new for the student because it is a new lesson for them. So they have not a lot of background or prior knowledge about the topic. So you can see from the table here, at least more than 30% of the corrected subtitles are faster than 20 character per second. So character per second is how we measure the speed. Means like for each second, you can see 12 characters on the screen. So according to the subtitling guidelines, the recommended subtitling speed is 12 characters per second, including space and punctuations. And the industry, such as Netflix, use subtitling speed of 17 characters per second, so a little bit faster. High-quality subtitles require text reduction. Since subtitles are actually transcription of spoken dialogues, and people speak fast, if we try to put the verbatim transcription onto the screen space, it will be too much. So we need to do a bit work with the text. And the second reason for not having a significant result is the low accuracy rate for automated subtitles. Because the low accuracy becomes detrimental for learning in this case. We use the WER, which is the word error rate, to calculate the accuracy rate. And we find out that the automated subtitle in these studies only have a 69% accuracy, so which is actually quite low. So the studies show that automated subtitles struggle with issues of accuracy, speed, and text segmentation. A recent study indicated that even AI-generated subtitles have an average of less than 90% accuracy across the 4 platforms it tests, including Microsoft and Google. The industry standard requires at least 99% accuracy for digital accessibility, and none of these platforms meets that requirement. High error rate in automated subtitles affects overall comprehension and compromise learning experience. It definitely disadvantages population who depend mainly or solely on subtitles to access information. Now we want to ask, how fast can we read without having to compromise our comprehension? There are many factors affecting the answers to these questions. We call it the holy grail questions. But the 2 recent studies on subtitling speed give us some idea of the answers. These 2 studies indicated that viewers can process subtitle speed up to 20 characters per second, but comprehension reduced substantially when the speed reached 28 characters per second. What happened there is when viewers process subtitles presenting in such a high speed, the Kruger studies show that more than half of the text were being skipped. Their processing becomes very shallow, and they also have much more reading errors and incomplete reading because students cannot reprocess the information when the subtitles disappear and a new subtitle appear on the screen. With an unfamiliar content usually happens when we are learning new information. This scenario reduces the overall integration of the video content. So in conclusion, automated subtitles are a good option to produce cost-effective on-screen text, but it is not optimized unless we can correct the errors to improve readability before we can use it. The use of eye tracking method in subtitling research can help us to further understand subtitle reading behavior and subtitle presentation to improve learning and information processing. I use eye tracking for my PhD study. So to wrap up my presentation here, I'm going to show how it is like to use eye tracking in subtitle reading research. So here we've got some video clip. You see different color represent different participant here.
Doesn't do anything for me. If I was going to go that way, I'm more of a Zac Efron kind of guy.
Okay. So not only doing this in subtitle research, we can also observe different subtitle reading patterns for different level of language proficiency. With low proficiency learner, here's like this.
Your argument is lacking in all scientific merit. It is well established.
Okay, and here is the high proficiency learner's reading pattern.
Your argument is lacking in all scientific merit. It is well established. Superman cleans his uniform.
Okay, so you can see very clearly with low proficiency learner, they depend more on the subtitle. They have more attention on the subtitle to understand the content. Whereas with high proficiency learner, most of their attention will be on outside subtitles and other information from the screen. Of course, this is my last slide. With the newly trendy social media we have, subtitles and captions are used on another level and being more creative. So here is on the left is we used to see on our phone or our device, or something like on the right side, very creative subtitle.
I feel like a lot of us have become a little too attached to our work, you know? We identify with our work. Have you ever asked somebody just randomly, be like, hey, tell me about yourself? And they'll be like, well, I'm an architect. And tell me about yourself. Well, you know, I own a hair salon. And tell me about yourself. Well, I'm a teacher. And tell me about yourself. And people will tell you about what they do. I feel like a lot of us have.
Okay, so that wraps up my presentation. This is the references. Thank you. And
Right.